Okay. In your calculator, I think what they do is they have it as a decimal. I think it's like, I don't remember what it is, but it is a decimal though, so, but that's okay. All right. Okay, so that's for 45 degrees. I didn't write down the other trig functions like secant, cosecant, and that. But you know, those you can easily get once you know sine and cosine. And cotangent you can get easily once you know tangent. Okay. I did present it. I did write down radians as well. You know, again, if you go on into like calculus and stuff, you're only going to work in radians. So I want everyone to see like what radians are. All right, well, we can actually get other trig functions at certain angles. If we take an equilateral triangle where each side is length 2, 2 actually we just chose to make the calculation easier. It really doesn't matter what side length you choose. Equilateral means all the side lengths are the same, but we just stuck with 2 for convenience. In an equilateral triangle, okay, what happens is, since all the sides are the same, all the angles have to be the same, which forces all the angles to equal 60 degrees. Then, what ends up happening is this. You can draw the angle bisector, I think is what they call it. And that's going to bisect the angle up here. So each little half here happens to be 30 degrees. Okay, now when you draw it, okay, what ends up happening is, since this is 30 degrees and this is 60 degrees, this angle is forced to be 90 degrees, right? Because the angle, the sum of the angles has to be 180 degrees. Okay, now how do I know both of these sides are the same length? Well, it turns out these two triangles are actually congruent to each other. You can prove that using side angle side. You know, you have this side here, right? You have this angle here, which is the same as this angle. And then these two triangles share the same side. So that's how they're congruent. I think you can also do angle side angle, so either one. But that's why they're the same. So essentially they're the same triangle. And that's why these two side lengths have to be the same. But basically from there, you get what's called a 30, 60, 90 triangle. So this is basically half. I mean, it's the right half or the left half, I don't know. But it's basically half of this equilateral triangle. The height is this dashed line. And I'm calling that h here, as you can see. But how do you get h? Pythagorean's theorem, right? H is a leg, so we have 1 squared plus h squared equals 2 squared, as I have here. And h squared is equal to then, you know, you solve for h basically, you get 4 minus 1, which is 3. And so h turns out to be the square root of 3. That's what ends up happening. Okay. And again, it's just like before. Once you know this side happens to be the square root of 3, you can determine sine of 30 degrees, sine of 60 degrees, cosine, and all that other stuff. That's what I'm doing here. You know, for instance, sine of 60 degrees, that's opposite, which is h, divided by 2, the hypotenuse. But h is radical 3. That's how we get that. For 30 degrees, here, the opposite side would be this, right? Remember, the side is labeled relative to the angle. So for 30 degrees, this is the opposite side. So sine of 30 degrees would be opposite divided by hypotenuse. Okay? That's how we get this. For cosine of 60 degrees, that's equal to adjacent over hypotenuse. So cosine of 60 degrees is a half. Cosine of 30 degrees, now this side is adjacent, relative to 30 degrees. So we have adjacent over hypotenuse. So for cosine of 30 degrees, that's h over 2, but h is radical 3. And then tangent, the same idea. Tangent of 30 degrees is opposite 1 over adjacent. H is again 1 over h, but h is radical 3. Tangent of 60 degrees, that's opposite over adjacent. H over 1, h is radical 3. So, I mean, again, you don't have to memorize these because, again, they're programmed into the calculator. I did write them out here, and I wrote them out and wrote the angles in radian form. So, and don't worry, you're not going to have to derive these on an exam. I'm not going to ask you to derive this triangle. Okay? I mean, for one thing, they do it directly in the book. I just figured it'd be good for me to go through it. So, okay. And again, these are programmed into your calculator. You just have to make sure that you're in the right mode. So if you're working in if you want to work in degrees, make sure your calculator is in degree mode. But if you want to work with radians, make sure your calculator is in radian mode. Okay? You know, if you type in cosine of 30, but if you're in radian mode, you are not going to get radical 3 over 2. So just letting you know. Okay, so I hope that wasn't too fast. Are there any questions on this? I mean, again, I'm not going to ask you to derive this kind of triangle and these values on an exam. I'm not going to do that. I just don't see the point in that. So, okay. So let's do some more examples. These examples are really nice because they show if you happen to know another angle in a right triangle besides the 90-degree angle, then of course you actually know all 3 angles. And if you know one side length, you can get the other side lengths using trigonometry. So if you know all the angles and one side length, you can get all the side lengths. So we're going to do that. So here we have the angle here is 37 degrees. This side here has side length 40 by assumption. Okay? We're going to find A and we're going to find C. I mean, the hard part is figuring out which trig function to use. Okay, so how do we do that? Well, notice that here we have the adjacent side, right? 37 degrees, we have adjacent. 40 is adjacent to 37 degrees, right? To the angle, I mean. A is the opposite side, right? So we have opposite. You know what? Actually, I wasn't going to do this, but let me do this now. Actually, let me type this in. I don't know why I didn't type this in before when I made the notes, but that's okay. There we go. That's better. Okay. SOHCAHTOA. Okay. You know, again, it's a good way to remember the what do you call it? The trig functions, right? So again, what do we have? Let me get the pen out. Trusty pen. We have the adjacent side, right? We want the opposite side. Well, what trig function are we going to use? Tangent, right? Tangent is what we're going to use here. And we know that tangent of 37 degrees is equal to opposite, the A in this case, over adjacent, which is 40. That's what we have here. So now it's just solving for A. Right? Oh, I don't want to do that. Okay, so how do we do that? Well, we know tangent of 37 degrees is A over 40, right? As I have here, you just want to solve algebraically for A. So you multiply both sides by 40, as I did. By doing that, these are going to cancel. And you get A is, well, you get 40 times tangent of 37 degrees is A, okay, which is equivalent to writing this. I just interchange both sides. Okay. But again, if you calculate tangent of 37 degrees in your calculator, okay, if you calculated that, you get about this, you get this amount approximately. Okay, and again, make sure you're in degree mode. Just check this actually. Okay. Again, you want to make sure you're in degree mode. Okay. If you do 37, then type tan. Yeah, you do get that. Okay, good. Okay, I just double checked. And then you just multiply that by 40 and you get this. A is approximately this amount. All right. Are there any questions on this? I mean, I'm not done yet, but are there any questions? I know on the iPhone calculator, the calculator, if you turn it on its side, you get the trig functions and you could tell it whether to be in degrees or radians for the iPhone. I mean, I'm guessing for the Android, it's similar, so. Okay, we're going to get C now. I know you're probably going to think, oh, Pythagorean's theorem. But again, this is trigonometry, so we're not going to use Pythagorean's theorem. So we're going to find C, but we're not going to use Pythagorean's theorem. Okay? But let me just go back to this. Okay, so here, if you want to get C, right, and we have 40, which is adjacent, right? Let me just change the colors on this. So here again, we have adjacent, right? And what else do we want? Well, we also have the hypotenuse, right? So in this case, we're looking for C, right? So we're doing number 2 now. Without using A, meaning without Pythagorean's theorem, we're going to find C. So we have adjacent. We want the hypotenuse. What trig function has both adjacent and hypotenuse? Well, that's this, cosine. So we're going to use cosine for number 2. Okay? So in this case, we have cosine of 37 degrees is equal to adjacent, which is 40, divided by hypotenuse, C. Okay? So that's what happens here.